go through and show you what the software does. How many people in here are actively doing data science work on a daily basis? Raise your hand. So most of you. How many of you use R or Python for what you're doing? Almost everyone. Okay, good. Good. I never know when I go and do these talks. Like, I went and gave a talk yesterday to a group of geologists and like oil and gas folks who are not data scientists, and so you never know who you're going to get. With you guys, we can skip a lot of the intro pleasantry stuff because you're already going to know about it. So, like I mentioned, we'll cover a little bit about what KNIME is, the company, and the software. I'll do a modeling demo. I'll just briefly show you some of the ETL visualization functions we have, but the more interesting stuff is really how do you build models and how would you compare models. Then at the end, I should have enough time to do a quick demo of our Keras integration. For those of you who are familiar with KNIME, I guess that's another question I should ask. Has anyone in here used KNIME before? It's like a third. Wow, okay. So for you guys, I can talk a little bit about what's new in our latest release 3.6 and what we're going to be working on for the next release in December. And then it says Q&A at the end, but if I'm talking and you have a question, just shout out. I tend to ramble, so it's good to break when I'm not making my voice. So KNIME, the company, this is a lot of text on a slide. I like to start off with the slide that immediately puts you to sleep. So I won't spend much time here. We're founded in 2008. Our main headquarters is in Zurich, Switzerland, but our largest office is in Constance, which is just across the German border. KNIME came out of the University of Constance originally. We also have a lot of our developers in Berlin, and we have about 6 folks in Austin right now. That's our US headquarters. We maintain 2 different products, the open source KNIME Analytics platform, which is what I'm going to talk about tonight. It's completely free. If I'm talking and you get bored, which I understand, just go download the tool. You have more fun with the tool than you will listening to me probably. Analytics platform doesn't have any restrictions on the number of records you can process or anything like that. It's free, download and put it. It's built on a visual front end, so it's GUI oriented. I'll show you that in a second. We blend all the different types of data, small data, big data, and then we use a bunch of integrations that I'm going to talk about. We have 2 releases a year, usually July and December, and we've had biannual open source releases since 2006. And as a company, we've really committed to the open source concept. So if you want to go and get our source code on GitHub and play with it and compile it, feel free. That's great. And I should say too, we initially released some of our big data resources last December as commercial products that you had to pay for, and that bothered our CEO so much that after a few months he said, no, we're going to make these open source too. So as a company, we're really committed to that concept. We do have a product that we sell, which I won't really talk much about tonight, but it's how we keep the lights on. People always ask, you're an open source company, how do you pay the bills? Well, we have a server that we sell, and that's mainly for things like the data science team. You want to be able to share workflows with each other. You want to have workflow version control. If you want to deploy a model using our REST API, all of that stuff is supported on server products. But as I said, what we're going to talk about tonight is primarily the free open source product. And there it is. So what you see right there is just the canvas for building workflow. Each one of those little colored boxes is what we call a node. And each node has a very defined task that it performs. So you'll see on the left-hand side there, we have a node to read in a file. There's a yellow node in the middle to do partitioning, to split data into a test and training set. We have nodes for training and testing, all sorts of different machine learning algorithms, and then nodes for scoring and visualization. What do our visualizations look like? Well, there's some of them. I know how much everyone loves to see visualizations of the iris data set, so I've helpfully provided one for you. I know you've seen that plot in a million other different contexts. So what do nodes do? Nodes perform tasks on data. So you'll see on the left-hand side, you'll have a little arrow, which is an input port, and then you'll have output ports. Could be 1, could be 4. On the right-hand side, that's just indicating how your data is flowing. The different colors of the nodes correspond to what they do. So in this case, a yellow node is a transformation node. Blue nodes are for visualization. Orange orange nodes are for reading. There's a whole kind of way that we approach that. How do you know whether a node has executed or not? You can look at the little traffic lights, which are going to indicate to you, hey, what's going on with the status of the node. And then as we showed in the previous slide, you combine all these nodes together, you just drag and drop and connect them with the little arrows to model the data flow. So we have, that should say over 2,500 native and embedded nodes. For all these different functions, I won't waste your time going over what all of them are. But it's of more interest is probably kind of the different colored sections. So we have nodes for data access. We have nodes dedicated to reading in big data from the cloud. All sorts of transformation nodes. I think the strength of our product as a data scientist is in data mining. The number of algorithms that we offer, there's a lot, and there's a lot of deep and robust capability there. And we also have visualization and deployment nodes too. One of the things that I say to folks who've never picked up KNIME before is they hear me say 2,500 nodes and they kind of go, why would I want to learn something like that? It seems like a lot. In your day-to-day use, once you're proficient with KNIME, you probably are going to use 150 or so of those. Large chunks of those nodes are for highly specialized things like image processing or chem and bioinformatics, text analytics, stuff that some data scientists may never have a use for. We have nodes to support those people, but you as an individual might not need to use them. So 2,500 or 2,000 or whatever is marketing speak, but don't let that go. As I mentioned, find yourself falling asleep, go to KNIME.com and download the product and just play with it. That's what I encourage everybody to do, especially if you already have some background in data science. You know kind of basically what the data science life cycle is, you'll be at home, okay? We have an introductory course online that just kind of walks you through data science concepts if you're not familiar with them. We also offer several books. The one that we have listed here, KNIME Beginner's Luck, for someone who's just starting out with KNIME and data science in general. But we have some other books that are more specialized. One that's really good is anybody in here do text analysis, sentiment analysis at all? So we have a book called From Words to Wisdom, which highlights all kinds of features that are specific to text analytics, which I think is really good, and I find myself referring to it a lot. The other thing is we have a pretty active forum. I'm on it almost every day, along with some of our other data scientists and our user community. So if you ever are building a workflow, or you think, hey, I might have a node that does this thing that I want to do, you can't find the answer, ask on the forum and somebody will help you out. So, before I jump into doing the demo, let me talk a little bit about what we want to do with this demo. So, it's going to be a classification modeling, and we're going to use data set from it's from the USDOT, right? Yeah, the Department of Transportation on-time statistics database. It's data from 2009. So this is data like from which airport, which flights are coming in, at what time of day, whether, how much time do they spend on the tarmac, how much time do they spend in the air, all of this sort of stuff. And then we're going to combine that with meteorological data from NOAA at the same time period. And we're going to use those two sets of data to see if we can predict departure delays for an individual aircraft, where we define a delay as something being an aircraft leaving more than 15 minutes ago. And I think we'll do that just for Chicago O'Hare. So before we do the actual interesting prediction stuff, as always with data science problems, you've got to do some ETL, you've got to clean your data, you've got to do some processing. And then I'll also show you some simple visualizations using not only KNIME's visualization tools, but our integrations with R and Python. And then as far as the models themselves, we'll look at all of these models individually and compare them to each other. So we'll do a random forest with Python, naive Bayes in R, a gradient boosted machine in H2AI, and decision tree in KNIME. KNIME natively supports all of these different algorithms as well as a whole bunch of others, but I just think it's cool to see the different algorithms in different contexts. It may be, as a data scientist, coming to KNIME, you say, oh, I've already got a bunch of models. Like, I'm a Python pro, right? I've already got a bunch of stuff written. Why would I want to use KNIME and reinvent the wheel? Well, you don't have to reinvent the wheel. You can bring your code in directly to KNIME and execute it there and take advantage of some of the other stuff that we offer. So we look at that for, folks who are already heavily into data science, look at this as a complementary product to what you're already doing, not something that's necessarily going to replace what you're doing. So here's a workflow, a flat picture on the screen, but it's much more interesting if I actually pull up the software. So can we see that okay? Okay, so when you open up KNIME for the first time, this is what you'll see. You'll see the welcome screen, which just has some helpful stuff. For your first timer, where do I go to learn about KNIME? Can I get some example workflows, et cetera, et cetera? What are the workflows I've been working on here? Before I open up the workflow, I'll just kind of show you around the interface. Over on the top left side is the KNIME Explorer. So this has links, in my case, to any servers that I'm connected to. Is that better? Yeah. Okay. Any servers that I may be connected to. The most important thing that you'll see when you log in for the first time, you won't see these four at the top, but you will see the example server. And as a data scientist, I think this is a really useful thing. If I double click to open the examples, this is going to hit our server, and organized by use case, you're going to see a whole bunch of different workflows. So if I wanted to, hey, what's going on? I'd like a sample workflow for cluster analysis. We've already got one for you to do KNIME. You can just double click on that, it'll download it right quick, and you can use that as a starting point for whatever analysis that you're trying to do, right? And we have hundreds of different example workflows. There's what if I want to optimize my model, if I need to do cross-validation for support vector machine, here's a workflow. So I'll always point that out to everybody first as a good resource. Any local workflows I may have on this machine, I've got in the KNIME Explorer as well, organized in the standard for the future. On the left-hand side here, also kind of for new users, is the workflow coach. So this is going to tell you for any given node that I may have clicked on, it's going to say, hey, what's the next most likely node? So in fact, if I open up the open source visualization and modeling, let me blow this up even more. If I go into my data processing node, if I click on the table reader, the workflow coach is going to say, okay, with an 11% likelihood, the joiner is the next most likely node, or the row filter, or whatever. So if you're not sure kind of what to do from one step to the next as you're learning KNIME, we give you some suggestions, and these are based on anonymized usage statistics. Where do the nodes live? The nodes live in the node repository, which is down here. They're all organized by their function. If I want to go in and, hey, where is my decision tree node? There's my lever and my predictor. So I can go down and I can search for nodes by their function. What I usually do, instead of digging through the tree, is I say, where's my partitioning node? I type in partition, there it is. I can drag and drop on the canvas. This guy at the bottom here is the outline. So this is just going to give me kind of a top level view. Okay. There we go. This is going to give me a top level view so I can click and drag around my workflow. I hope this is useful if you have really big workflows. Then over here on this side is the data node, or the node description. So for any node that we have, if you click on it, you'll get a description of the possible inputs, the possible outputs, all the options that you can set. And if it's an algorithm, it'll usually have a link to the white paper or whatever academic paper that the algorithm is based on, so you can go get more information on it. Okay, all of that said, that's what the interface looks like. We make some of this stuff go away so we can actually focus on the toolbar. So as I mentioned, this workflow is designed to predict airport delays based on this data set that we have, do a bunch of modeling on that data set, and then compare the results and do some simple visualization. So the place that we start is in this data pre-processing meta node. A meta node is just a collection of nodes. So anytime you see like a little gray node like this, that's a meta node, and you can double click on them to dive in and see what actually is going on. You'll see in this case, we actually have meta node buried within meta nodes. So it's a useful way to kind of organize what's going on. Yes?
So maybe you just answer my question about that last statement. So that's just a stack, if you will, of nodes for visual simplicity?
Yes.
Okay.
Yeah. There are cases, and I'll show you later, where we have wrapped meta nodes where there's actually a functionality if you want to display certain visualizations in a particular way. But for the most part, Meta nodes are just used to organize your workflows. You'll also see things like, oh, we've got this big blue box here, you know, which is giving us some information, some visual information about what's going on. The orange box is listing, you know, sources for the data. So you can do annotations for your workflows, and then you'll see each one of the nodes has a description, right? If I just click on that, I can edit that description to be, you know, whatever I want. But it's useful. You know, it's like, you know, putting comments in your code, right? You put comments and annotations in your workflow, so that you, in 6 months from now, when you go back to it, you can remember what you did. Or if you have to hand it off to someone else, maybe they'll be able to understand what you did. So that's all, you know, part of it. So what we're doing here in this initial data preprocessing meta node, we're reading in a data file. Here's the very first conversion we do, string the date and time. Oh, and I should show you, each node has a configuration, right? So if I double click on any node, it's going to bring up a little dialog. In this case, it's the table reader, so it's going to say, hey, give me a path for the table. And, you know, everything's already been pre-executed here, so you can see that we have green lights all over the place. But the string to date and time node, so this is going to take, you know, a string that's provided in the original data set, and it's converted to a date and time. And so I have to give it the proper format, of course, and tell it whether it's just a date or date and time. I won't go through all of these with you, but just so that you get an idea, for each individual node, everything has a configuration. At each point along the workflow, you can always look and see what you've done. So if I take this string to date and time node, you know, it transforms strings to dates. If I right-click and look at the output table, I can see what was actually done. I can see way over here, this is my entire data set up to this point, and I can see way over here on the right-hand side, I've created a date column with the proper format. So at each spot along the way, you can say, oh, I did a math formula node to do a calculation on a particular column. Did I do that right? You execute it, and then you can, you know, right-click and look at the data to make sure that you did do it. So some of the other things we're doing here, you know, as I mentioned, we're blending data from other sources. So inside this meta node, we're reading data from a list of airports and cities. We're going to read in meteorological data. After we read everything in and cleaned it up, I won't show you all of that because it's kind of notes and you're never going to know. But since this is a demo, there's a point where we have a nice clean data set. We can just skip all the painful part that data scientists is boring and we like to do. There gets to be a point where we have a nice clean data set and we actually want to do a split into a test and training so we can build on this. And that's what's happening here. In this particular case, it's a little bit weird because we're going to split the first 15 days of this particular month, January. We're going to use the first 15 days to predict the second 15 days. That's typically not what you would do, right? Normally you do some sort of stratified sampling on your data. So most of the time you would use this partitioning mode, where I could say, hey, I want 80% for training, 20% for test. I can use stratified sampling on my target column, in this case, the target delay, and it'll just do that for me. So what we have coming out of this node, and that we're going to feed to our other nodes, is a training set and a test set. Before I actually show you building the models, I should show you some of the brief visualizations that we have here. So maybe I want to do, you know, I want to get a feel for what's in my data set before I start feature creation, or if I need to do dimensionality reduction and get rid of some fields that aren't important to me anymore. First, I have to understand what's in the data. So we have this node, the Data Explorer JavaScript view. If I go look at the view of that, then at a glance, I can see, all right, you know, what might be something useful. Here's the departure time with the minimum and maximum. You've got some like kind of basic statistics, variance, skewness, and kurtosis, and that sort of thing. And then you've got a little histogram that's automatically generated on the side here. Now, granted, all these histograms might not make sense for every variable, right? It's categorical or something, but it tries, and you can see at a glance, you know, how my data shapes up. So that's just a simple thing you can do there. What if I wanted to do, for my meteorological variables, for example, a box plot? You have a box plot node. So these are some of the continuous variables, you know, like here's the maximum temperature, the minimum temperature, in Chicago, so this is cold, right, in January, it's really cold. I can just see at a glance what's going on there. If you would prefer not to do visualization with our nodes, or I'm sorry, our nodes, as opposed to our nodes, we have views that you can use with R and Python. So those of you that know R, let's say that I wanted to do a pairs plot. If I know my R code to do that, I can use the pairs function, just pass the data in and say, hey, you know, give me a pairs plot and also fit a regression line on it. So I'm basically just writing that code here. When I do that, look at the view. And so there I have a pairs plot, right? Yes?
You have it, so I'm more of a Python guy, but still library to library. So how does that work? Do you have to have R or Python on your machine and it has to activate both of them and then it creates a link? Or are you simply, have you embedded those libraries in KNIME and it's encapsulated within the KNIME file?
So KNIME actually ships with a version of R that's pre-installed.
Okay.
If you have a different version of R on your machine that you would rather use, then you can point to that. But it actually is calling R and executing R.
Within the libraries encapsulated within KNIME.
That's right.
It calls that module just like.
Right, so what KNIME does is it says, it looks at the arrow that's coming in and it contains the data, and it says, okay, I have this data set, I'm going to take that and pass it to R as a data frame,
Okay.
and using that data frame, perform these operations, return the image, and then that's what the node displays.
So it's actually probably more efficient than having KNIME reach out to a separate program on your computer, right?
Yeah, hopefully it's a little bit more efficient. Yeah.
What about your own library?
I'm sorry?
What about your own library?
Yeah, you can maintain all of that. Yeah, in fact, yeah, and oftentimes, right, you need to install a new package or whatever.
Or
to-
stuff that I write myself, like I want to put that.
Yeah, you can call all of that, for sure. Yeah.
Are there more coding stuff to get into if you reached out to a library outside of KNIME, our library outside of KNIME? Is there more coding to do to get the handshake to take place?
No, you just say, it's just like regular R code. You just say library, ggplot2, whatever, and it's it. I will say, I mentioned that R ships with KNIME. The Python integration doesn't ship with KNIME. It's like a one-time install and setup you have to do. Like we tell people, go get Anaconda. We have a little introductory blog post on how you set it up. You have to set up a Conda environment that has its very specific libraries in it. But once you do that, you go into your preferences, you tell KNIME where that environment lives, and it's off to the races with Python 2. So, in fact, I'll show you that. So this is, instead of the R view, this is a Python view. So here, you know, I'm importing pandas, I'm importing matplotlib to do the plotting. You know, data is being fed in via the little arrow so that Python sees it as a data frame, knows what it is. And basically, I'm building, you know, sad to say, the redheaded stepchild of views is the pie chart. Right? So this is not an exciting view. Okay? It's days of the week. So no one's going to get real excited about this. For the purposes of demonstrating that I've generated this plot within Python, it's okay. But, yeah, just one second. Yes?
When you pull these views, normally there's some code which comes to them. Which ones can you delete and which ones do you have to keep to make them work?
I'm sorry, I don't understand.
Like when you pull one of those nodes, there'll be a snippet of code which comes with it.
Yeah, I had to write that. Yeah, you're not provided with the code to do this.
No, there's normally something, there's a little bit of code inside. What can you delete and what do you have to leave in and what can you delete?
Well, I mean, it's just like a little tiny embedded Python program, right? So, you know, I'm going to go in and I'm going to say from IO import, you know, I'm going to import the libraries I need, right? And then I'm just writing Python code that is active on a data frame. So, it's just code. This is the same code you use in Python, you get the exact same plot. Very boring plot. Yes?
So right now, sometimes I use library from Python, but I work mainly in R, so I use particular to pass things back and forth.
Uh-huh.
So if I say I point the error of the output, a data frame, an R data frame, to your Python code, which is Panda series, is there an intermediate KNIME object that knows where to convert it out?
Yeah, so KNIME would be doing that in this case. It's gonna, if you went to R first, it goes in as a data frame, it comes out as a KNIME table. That KNIME table then goes into a Pandas data frame and comes out as a KNIME table. So, yeah, anytime, we haven't really talked about this, but anytime that you have the little black arrows here, that has a specific meaning. I don't triple this in back. It has a specific meaning. The black arrows represent a KNIME table, which is our internal format to move information around. You'll see these green boxes here. The green box means an image, right? We have a whole bunch of other different nodes. We have blue nodes. Blue boxes are for models like KNIME. Red boxes are database pass-throughs. Brown boxes are queries. I mean, there's all sorts of different ones. You know, just like the nodes kind of have a color scheme, the ports also have their own color schemes too. So, yes?
And just going through the flow, are little files being created locally or on the server? Or are they encrypted?
Are little files being created? It depends, right? Hopefully these are just staying in memory if it's small enough, right? So that we can be efficient. But yeah, sometimes things are being written. Encryption is part of our server process. So you can do that on the server, locally on your machine. Yeah, stuff is, it's all writing XML, basically. So just a little bit on visualization. There's much cooler stuff you can actually do here with some of the JavaScript visualizations that I haven't shown, because the main point of this talk is you can do it in KNIME with our stuff, or if you would rather write code in R Python, you can do it that way too. And I mean, for some, ggplot2 is really good. There's Altair in Python is a really amazing library. I mean, there's some really great visualization tools that can do lots of good stuff that we don't do. In fact, we have a couple of nodes that write out the Tableau, but people do it in Tableau. We just want to play nice with what's out there. So if you don't like our visualization tools, it's fine. Use whatever you're comfortable with and what you prefer. So let me talk a little bit about building models. So if I go down here, first I'll show you the KNIME way that we do it, and then I'll circle back around and show you the Python and R ways. So if I go down to this KNIME native decision tree meta node and click inside, remember we're passing in test data and training data here. I should say training data and test data. The training data comes from this port and goes to the decision tree learner. The test data goes to the decision tree predictor. We kind of see this this motif in all of the different ways that we build models, whether it's with decision trees, random forests, gradient distribution, whatever. Everything has a learner and everything has a predictor. And so you're always feeding your training data to the learner, your test data to the predictor. So in this case, this decision tree is a simpler machine learning algorithm. So this is if I want to click on here, I'm using just defaults. The only thing that I've specified is the thing that I'm actually trying to predict, which is at the top of the departure delay. You can make other changes here if you wanted to do pruning, for example, or you can specify, like in a random forest, you can specify the number of trees and how deep they go, that sort of stuff. All of your standard options are there. But I'm not doing that. Having already trained the model, I have a couple of different views. So one of the nice things about a decision tree is it actually is fairly interpretable compared to some other things. So we actually have a little view here that is going to help you. What's the most important distinguishing variable at the top, whether something is delayed or not. For departure, it turns out that arrival delay is pretty important, right? This data set's funny in a way. When we get to the rock curve at the end, I'll tell you why. I might have built this a different way if I had known more about the data set when I first started at KNIME, because that's silly. But anyway, yeah, it turns out that arrival delay is important for departure delay. Surprise, surprise. But if you click on the little plus here, right, then we can drill down into all the different things that are the rules that make up the decision tree, and we can just go on forever. It's really exciting, okay? There's also another view as well that's a little more compact. So, with these pie charts, where I can do the drill down, but it actually, fits on the screen in a nice way. So now that we've trained the model, I think on this case it was a half and half. It was 15 days and then 15 days. The trained model is being passed out on this blue board. If I mouse over it, you can see what it actually is. The blue board is a PMML document version 4.2. And we pass that PMML model to the decision tree predictor for use on our remaining rows. There's not really much to set for the decision tree predictor. The main thing here is I'm going to click the option to be able to spit out the probabilities from my normalized class distribution. Otherwise, I just get the prediction of whether there was a delay or not a delay. I actually would like to know there's a 95% confidence, there's a 45%, whatever, so I can do the rock curve. The results of the decision tree predictor get passed to our scorer node. So this is where you're going to find, the confusion matrix. Since it's a binary class problem, we have a small, tidy matrix. So we can see at the top are true positives and true negatives, false positives and false negatives. The accuracy here is the hilarious 94.2. So you can see that at a glance, right? But we know that accuracy is not necessarily the most indicative measure of how a model is performing, but we provide it for you nonetheless. If you want some more specific information, you can go to the accuracy statistics, and here you can see things like sensitivity, specificity, F measure, in addition to the overall accuracy and so forth. Probability speed, yeah. So all that's available to you. The rest of these nodes here I won't talk about much except to say they're doing some mild transformations on the score output to produce the rock curve. So that's kind of the 90 way of how we would do something like that. You're building a simple decision tree. What if we wanted to do this in Python? Well, you can see that the nodes look really similar, right? And so we have the same scorer, we have all these same post-processing nodes to spit out to the accuracy table into the rock curve, and we even have a learner and a predictor, so that's the same. It's just that when I click on these, instead of a nice GUI, I get code. Okay? So what am I doing here? I'm going to import my random classifier package, import pandas, basically setting my feature space to include certain features and skip over other ones and just make an array. And then I say, hey, I'm going to have an output model do the fifth one. As I'm writing this code, in this case I just copied and pasted from somewhere else, but if you want to actually write it in here, you can highlight the portions that you want to run, and you can execute selected lines. You can run the whole thing at once, just like you could in maybe a prettier IDE like Jupyter Notebooks in our studio. But it still has the same functionality. And then if I do that, I'll see messages in the console here. So we've built a model using Python. Python predictor node, much the same. We have additional code that just defines our feature space, and we're going to write out the prediction along with the probabilities. And oh look, I've even got a helpful error message about deprecating some library that I'm using. So I guess I should go up with that. But very much the same thing, right? So what we end up passing out here is an accuracy and the prediction probabilities. In terms of speed, you're not seeing any of this run in real time. This data set isn't that big, but I think the KNIME decision tree is fastest, followed by Python and H2AI, and then R. For whatever reason, light-based implementation takes a little while. So again, here's something else where we're going to use, instead of a Python learner and predictor, we'll use the R learner and predictor, because R is cranky about having spaces and field names. I had to insert some column renamers in here to fix that before I actually trained the model. But very similar to Python, I double click this, I have a little IDE, and here's my R code for building a naive Bayes model. Those of you who are familiar with R, one of the things I like about it is it's very compact, at least for the model building part. I've got one line here that basically defines the model. So I won't beat you over the head with all that. A lot of it is the same. One thing that I do want to show you. So has anybody used H2O AI algorithms? Okay. So they're great, right? They're super fast, written by some really smart guys at Cal Berkeley, and they scale super well. So for a data set like this, you're on the order of tens of thousands of records, you're not going to notice the difference. If you have billions of records, it performs very well. Like if you compare H2O AI to standard Python or R execution times on the order of billions of records, you can see 2 orders of magnitude increase in execution speed. So they're super fast for large data sets. And we have that built into our product because H2O AI is open source and they like us and we like them. So I like to use their algorithms whenever I can, just because I think they're cool. One of the things that's a little bit tricky, tricky is not even the right word, it's just an extra step. You can see normally, you know, I would just pass the training data and the test data directly into the learners and predictors. In this case, because it's in H2O, I have to kind of convert things into H2O names. So I create a local context on my machine, and then I have these table to H2O nodes, which then convert using these orange ports the data into very specific H2O format. And then we're using the same learner and predictor motif. You know, this is gradient boosted machines, so what can I do? I can go in and I can say, hey, I want to include these features or not. I can set the tree options, the number of models, all that sort of stuff right from the GUI. And if you really like to mess around with the algorithm settings, here they are. The giant library. So again, learner predictor motif. We train the model, we test the model, and before we do the scoring, we have to convert from H2O space back into KNIME space. We do that with this node, and then it's off to the races again with the score. So we have all of these different models, in this case that we created, these 4 models. So we have 2 different ways to evaluate them. We have where you can just look at the accuracy, so I can actually just concatenate the accuracy results that we get from each one, split that to a sorter, and say, okay, which one is the most accurate? And this is a little bit hard to see, but it turns out that the H2O AI gradient boosted machine is 97% accurate, and the worst performer is the naive phase at 91.5%. But, you know, accuracy, who cares? Let's look at rock plots as first. So if we combine all of the different rock results together, we have this rock curve JavaScript visualization tool. I'm going to show you the results of that. This is where things get a little bit silly as a data scientist, but it's still a pretty plot. So what is this showing us? This is showing us true positive rate on the y-axis and the false positive rate on the x-axis. So we want things pulled up to this top left corner. We can minimize our false positives and maximize our true positives. And the area under the curve is a good indication of how the model is moving, right? And you can see they're color-coded. The H2O AI gradient booster machine has predicted with 99.6% accuracy. Who believes that? I don't believe that for a minute. I think that's garbage, and I'll tell you why, because you're in a data scientist and you'll know why. There's leakage in this data, right? And we saw it in the decision tree. Why would I include arrival delay if I was going to be predicting departure delay? Of course that's going to dominate the results. If I take the arrival delay out, I'm not going to have 99.5% or whatever accuracy, right? I probably shouldn't have been there. It's just kind of ruining everything. So, but that's a common problem. Yeah, Charles.
So on the context of, hey, you come up with something and you think, you know, you have some leakage in your term that you're using there. How easy is it to go back and tweak the model? Because if you got to this point, you want to go back and modify something because you think that you either want to add or remove a variable.
Sure.
How can you do that?
I could go back into my model training nodes and just filter that out. You know, once I figure this out, I have a good idea that it's a bad idea to have a arrival delay in there. Then I just take it out and put it on the model. And so it's pretty straightforward. And then everything downstream is going to flow, and I'll get a new, you know, rock plot and everything. And all I have to do is remove that one thing. So it's an easy fix in this case. I mean, there may be other cases, right, where you have these insanely good results, and it's a little harder to tease out what the problem may be. Or you may have something, right, that falls along the coin flip line, the 50% line, that's just complete garbage, and you're not sure what you should do next, but that's not a KNIME problem so much as this is a data science problem. But anyway, I want to show you this plot because it is, I think, a nice way to compare the results of these different models at a glance, even though the results themselves are a little bit ridiculous. Okay, so that's this workflow. I think that's all I wanted to show you here. did anybody have questions about kind of the ETL model development visualization comparison step before I go talk about deep learning a little bit? Ah, good. Yes, sir.
What sort of tools are there for exploratory data analysis where you may have found that high correlation before you got to the data?
So we have a correlation filter node, or we have a correlation matrix node where you can actually see if there are correlations. And then you could do a filter where you can say, you know, if I have a correlation that's above this value for between these two particular ones, throw one of them out. And then you have that happen automatically, so that if you have a data set with hundreds or thousands of features, you obviously don't need to do it manually, you can automate it, right?
Some of that is poking around the data set, you can discover things that, you know, the before as opposed to the after, and you found your rock curve and you got suspicious and then you go back and then
Right.
So are there tools, I'm sure there are tools to set up in front to kind of do that poking up front.
Yeah, like there's, you know, the Data Explorer node, you could look at the different, the distributions of the data, as, you know, before you really dig into things. The correlation matrix is a good example. There's a whole set of feature selection nodes here that I haven't included, or that we're not discussing rather, where I could go in and filter out, you know, a bunch of different features that could be muddying the waters, and just get rid of them ahead of time. So there's a bunch of that too.
Well, I think depending on what you find, it may change your structure. If you've got a large set of nodes, node network, then it would be a pain to have to wait again. You know, so
Right.
Otherwise, if it's a small tweak, like you're saying, no big deal, you go back to the beginning, you push go, and you start over again. You don't have to restructure your network.
Right. Yeah, I mean, in theory, right, you would have already found this rather obvious problem before I did, and fixed it before you do all the building of the model. But yes,
If you copied that like Python random forest code, and you just renamed it and opened it, you could flip out some of the other nodes, like for another particular model.
Mhm.
You have to remap a lot.
no, yeah, you can copy and paste it. Yeah, and if you wanted to implement some completely different algorithm, just copy and paste it, bring a code out, bring a new code in, you know, probably change your annotations a little bit so that you can distinguish between them. But yeah, like copying and pasting and reusing of those, I think is a real strength. Yeah. Yes?
Can you write back the database?
Yes. Yeah, I'm not showing any of our database features here. Basically, we're just reading in a flat file off of a local machine, but we have a whole series of nodes that deal with whatever flavor of database you want to read from or write to. A lot of common databases like MySQL or Oracle, we have dedicated nodes for, but pretty much if you have even a weird database that's not that popular, if there's a JDBC driver for it, we can talk to it. So reading and writing, and even in database operations are supported.
Is this support for parallelizing some of the notes, I guess? No pun intended, but, like,
Is what for parallel?
say for example, I have 4 models right now. I have 4 cores, I want to assign 1 core.
Oh, yeah, right. The software will parallelize to the extent that it can.
Cores.
Yeah, it's automatically going to do that. It'll distribute across the available cores that it knows about. And we have, again, stuff I'm not showing, but we have some streaming capability as well, so that if you do have a larger data set, you know, millions of rows, and you don't want to like try and load all that into memory at once and do all the operations and stuff, you can stream it in and define the batch size. You can say, hey, do 10,000 rows at a time, and it'll stream, and you can improve your calculation time dramatically that way.
Well, now you mentioned streaming, do you have an OS like Pi connector?
Can you say it again?
Do you have OS like soft Pi connector? The Pi store?
Don't know.
Okay.
Oh, wait, for Python storage?
No, Pi historian, like,
OSI is a tool set out Pi historian. So it's commonly used for instrumentation in the oil and gas field.
No, I don't think so. Sorry, I haven't heard of it. Charles, did you have a question? Somebody over here did.
Yeah, it got answered along the way.
Oh, okay. Fair enough.
Hey, but OSI Pi does, if it's going to have like an OBDC type of connector to it, which I think it does, that should be able to connect to it.
well, right now I just pull from off, so, yeah.
So are you talking about like real-time sensor data
Right.
input? I mean, possibly. We should talk offline. There might be a way to do that, but I'm just not aware of. But, Yeah.
You mentioned you can distribute your calculation across different CPUs?
Mhm.
How about across different nodes? Like say I have a cluster,
Across different nodes.
like different computing.
Oh, yeah,
computing
yeah.
computers.
Our server product can do that. Yeah, distributed execution, yes. The analytics platform is not gonna do that, but for our server, we can. Yeah. So let me talk to you guys a little bit about Keras and deep learning then. Different workflow. Again, I'll blow this up. Has anybody used Keras before? God, man, that's rule. I asked that question invariably. Blank stares and silence. So I'm not a pro with deep learning by any means. I don't want to give the impression that I am. So some of you may know more about this stuff than I do. But I do want to show you kind of what our integration looks like within KNIME. So a little bit about this problem. Are you guys familiar with the NNIST digits data set? So it's a really well-known data set of handwritten digits. There's images, right? So somebody writes the number 7, there's an image of the number 7, and the task here is to actually predict, based on the image itself, what number did somebody write, okay? So that's what we're gonna try to do. We have this meta node here where we're reading in, I think we're reading in 10,000 images, and we're gonna predict 1,500 images. So we read in the data here. I won't really go into the reading in part. What I think is more interesting is there's two different ways to specify the structure of the neural network. So we have this here, the DL Python creator, network creator node, which is a convolutional neural network. If I open this up, it's our friendly old Python IDE again, where if you're familiar with this, it's basically just saying, hey, my Keras backend is TensorFlow, import Keras, set up my libraries, and then I'm going to define things like I want a convolutional 2D layer of this certain size with this activation function. I'll have cooling layers, drop out, flatten, all of these sorts of layers that are typical in a deep neural network. Compile it and execute it. So when it does that, it's passing. It's created this neural network that's very specific to the shape and size of our images, which in this case are, I think, 28 by 28. Not GIFs. Anyway, they're 28 by 28, which is the important part. So that's one way to do it. If you're familiar with deep learning in Keras, is to just write the code, right? The other way to do it, and this is relatively new within KNIME, is to specify the different layers in the network using a series of nodes. So you can see here for the Keras convolutional 2D layer, if I double click on this and look at it, I'll be able to specify things like how many filters, what's my kernel size, in this case it's a 3x3 box. So I'm going to be taking a 3x3 box and doing convolutions over the 28 by 28 image, 1 pixel at a time. So that's what it's doing. And when it's doing that, it's looking for things, doing edge detection, it's doing blur detection, it's trying to come up with a mathematical representation of all these different permutations of what the image could be. I think that's a terrible explanation, but hopefully some of you are familiar with it, kind of know what I'm talking about. So there's a convolutional 2D layer. There's different layers which are intended to reduce the dimensionality of the data set, like the dropout layer and the flatten layer. Basically, this is, you can think of deep learning as this giant, filter shaped thing. And on one end, it's this big, huge box consisting of a whole bunch of different little pixels in the case of our image processing. And it's filtering down until we get to a point where it can make a decision. It has 10 output nodes, which are the digits 0 through 9. And it's going to assign that image that it sees to one of those different digits. That's what this is doing. I just show you that because it's, if you would prefer not to write code, you can do this just by stringing a bunch of 9 nodes together. So here we have the Keras network learner, which is where you're going to set all sorts of different options. Basically we're saying, hey, read in this image as my input, and then as a target, give me the integers 0 through 9. And then use the neural network that I've defined previously to do that. And then, here are the options if you want to set the number of epochs, and the batch size, and the learning rate, which optimizer you want to use, and we support a whole bunch of different optimizers. All of that really fancy stuff is in there. When you do that, and you actually execute it, oh, I should show you this. So I've already executed this on this particular data set, which is training 10,000. This takes about 3 or 4 minutes to run through 5 epics with a batch size of 50. You can actually see this running in real time when you do it. You'll see the accuracy. Let me do this in one scale. You'll see the accuracy gradually increase as you go. The model gets better and better as it reassigns weights within the neural network, right? And then you hopefully you see the loss gradually decrease. Now, if you're running on a really big data set and you just kind of are trying to play around and get your footing and figure out what's going on, you may not have time for this to finish, right? Because this might take days on a really big data set. So what you can do is if it gets to a point where you think the loss is reasonable or the accuracy is reasonable, you can just stop it. You say, learning stop, use the weights that I currently have, and go on and do predictions based on that. And we'll see how we do, right? It turns out that if I run this particular neural network on this problem for a really long time, like a day or something, you get almost 99% accuracy. I forget what, well, I'll look at the accuracy in a minute as to what we've gotten for running it for 3 or 4 minutes. It's not really that good. But it can be really good if you let the deep learning network do its thing. Yeah, Charles.
And the way you're describing that, it sounds almost like you're overfitting it. Is that taking that into consideration that you're not going through the repetition of learning to the point that you're overfitting?
Well, you could be, but some of the model layers, like the dropout and the flat layers, are intended to prevent that problem. And there's some academic literature about that I'm not well versed enough to be able to describe to you right now, but that basically addresses that question that you're asking.
Thank you.
Yeah, it's definitely it's a known problem, but there are ways to get around it. Yes.
So I know in other commercial software like Java, they allow you to export the internal models as Python code.
Yes.
Yeah. But like can KNIME?
Yeah, we typically export as PMML.
Okay.
But depending on the environment, you can export as Java bytecode so that you can execute it somewhere else. You can also export it as SQL to run it within the database, depending on the type of model that it uses. It doesn't work in all applications. But yeah, we try to provide a few different ways to export so that you can deploy somewhere else, basically.
Thanks.
Sure. So, so what have we done at this point? The workflow, we've created a neural network based on the definition that we give. Then we've done some training using these 10,000 handwritten images. And then we've got our test data and we're going to apply it using the network executor. And just like we do with our other predictor nodes, you get a classification and then you get an associated probability. So, and there's some boring formatting that needs to go on that I won't get into. The interesting part here, we have this image viewer coming off. We can actually see how the model did. So let me pull this up. I think this is more fun to look at. So here's a case where we have a probability of 1, basically. The model is absolutely certain that it has detected the numeral 7. It turns out that actually is the numeral 7. If I click on the image, yeah, that's a 7, right? And this it was a, 28 by 28 p is what this is. Okay. More interesting, probably, is where is our model performing poorly? Because we kind of look down the list here and we see there's one that, here's one that has it's only 70% sure. It still got it right. It said it was a 3. It is a 3. Well, I can see why it was confused. That's kind of maybe almost an 8. Who knows what that exactly is. There's one in here that it gets wrong. Oh, this guy right here. So this, it said with 38% confidence that it was a 6. It was actually 5. I defy you to tell me what that is. That is a sigma. That's what that is. So you can see at a glance. I'm not going to go through all the images. Obviously, you really want to. Because another thing you could do is you could look at the confusion matrix just to get that at a glance. This is the JavaScript version of our score node, which provides a confusion matrix. So since this is a multi-class problem, we can see, all right, where does the model do well? It does pretty well for the number 1. You know, so if it's a 1, it's 97.8% accurate. You know, if it's a number 8, we struggle. You know, only 85% there. But you can see our overall accuracy, even when we ran this for 4 minutes, I think whatever it was, is 94.1%, which is pretty good. And as I mentioned before, you can get this 99% plus if you're willing to run it for several hours. Then again, this is a classic problem with a classic data set. It's well-known and well-defined. If you're doing image analysis on your own, probably your results aren't as good unless you're a super amazing data whiz. So anyway, this is just a kind of a 10-15 minute explanation of how we implement Keras and TensorFlow within KNIME. Again, tons of examples on the example server about this stuff. If you're with some of the other applications for image processing anyway, we have a hard drive manufacturer that takes images of the surface of their disk during manufacture, and they look for defects before they make them off the assembly. That's one thing. There's a whole bunch of pharma and biomedical research into cancer cells that uses image detection sort of stuff. I shouldn't imply that deep learning is only used for image processing, because it's not. It has applications in all sorts of fields. We have some sample workflows for deep learning, for punishment, and text analysis. It's a little bit challenging. So anyway, were there any questions about this? Yeah, just another brief section I wanted to talk about. Yeah.
If I had a deep learning model or any model trained somewhere else, right? I just want to use KNIME to deploy it.
Yeah, assuming we could read it in. You know, if you have it built in Python or R, you bring in the code, right? We'll execute the code. If you have it in PML, we have a PML reader where you can bring, some model code, or not model code, generated model structure in already. There are ways to do that. We don't support
like the structure and weights, right?
Yeah.
If I had that somewhere,
Yeah, I mean, I'm not going to say either we support every possible format file that's out there, but we try to support as many as we can. Yes?
You export like a Python notebook or some kind of notebook from like data groups or something like that. Can you bring that in?
Yeah, so actually one of the things that I probably should include in this and haven't had a chance to yet because it's relatively new, we have a blog, I think it's a blog post that demonstrates going not only from KNIME to Python, but from Python back to KNIME within a deeper notebook. So Python actually calling an external workflow to do some analysis that happens in the background, and then those results are returned back as a deeper notebook. So you can go both ways with it. That's relatively new functionality. Anybody else on this stuff? Or really any stuff? Okay, well, let me switch back then to slides. Some of this we already covered. I can pass these slides around, by the way, because the stuff here is like, how would I set up Python within KNIME? We have a link for that. How do I download extensions for things like text analysis or image processing that don't come with the default platform? We have instructions on how to do that. We talked about deep learning. And all I talked about tonight was Keras and the TensorFlow backend. If anybody is familiar with DL4J, we actually have supported DL4J since KNIME 3.3. Has anybody used DL4J before? Has anybody used Word2Vec or Doc2Vec in text analysis? That actually is DL4J. We support that too. But I mentioned it just in, there's some folks out there who prefer it. We have nodes that are dedicated to that. Let me talk. Are we doing good on time? Okay. So I'll talk a little bit about, for those of you who are familiar with KNIME, some of the stuff to do in 3.6. I won't really talk about server very much. So we have a whole new series of nodes in 3.6 that deal with Git. So if you wanted to use KNIME to monitor your software project, who's committing, who's making pull requests, you can actually build a workflow that's going to pull that information out of Git, and you can analyze that directly. So that's new in 3.6. Yeah, sure. Does anybody use Apache Kafka at all? So it's kind of, I'm not that familiar with it, but my impression is it's like this Amazon query service. It's basically, Kafka is a service that has a series of dedicated instructions that it's passing on out of the queue. So KNIME can read that, which is, anyway, if you've noticed familiar with it, I won't beat that dead horse. A couple of new functional nodes. So we have ways to handle numeric outliers now that we didn't before. Like normally in the past, you would have had to calculate the outliers directly, using 1.5 times the interquartile range or whatever it is you wanted to use. Now we have a node that'll do that for you automatically, and then you can tell it, if there's an outlier, do you want to do some sort of imputation on it? Do you just want to toss it? What do you want to do? Yes.
On the topic of outliers, kind of depending on what you want to do, some things you want a tight tolerance or a wider tolerance or a specific range.
Right.
If it's automatically calculating that, is it something that's configurable?
Yeah, it is. And you'll see right there in the bottom left, like it's going to, by default, it's going to say use 1.5 times the interquartile range. You can narrow that or widen it if you want to. And then there's different quartile calculation methods too. So that's customizable.
Okay.
Column expressions, this is just a new node. This is really handy for building rules based on multiple columns at the same time. Or if you wanted to find, for example, like you have a whole series of dates in columns, which one's the minimum date? I can do that here. And you can see it's just using some simple Java admin expression that's going to calculate a new field based on the attributes in the existing field.
So feature engineering.
Yeah, it's just instead of having, like before, some of the stuff you would have to string together a series of nodes to do it, and now you can just do it. If you're willing to write just a tiny bit of Java. Big data stuff. So one thing we didn't talk about tonight is KNIME support for Apache Spark. We have already supported previous versions, but we now support 2.3. We have a couple of new nodes that are used for that. What's coming up in December is we're going to expand our support for Apache Livy. So that gives out-of-the-box Spark compatibility with these different frameworks here, in Hortonworks, Amazon EMR, HD Insight. So just more ways to deal with your data in the cloud if you need to. This, I think, is the coolest thing that we released in 3.6. How many of you guys use Hive or Spark or Impala ever? Okay, so a fair amount. As far as I know, we're the only software that has this feature available. It's a drag and drop node, create local big data environment. This is a bit of a mouthful, but you drag and drop it, and it gives you the ability to have running on your local machine, Hive, you can see HDFS, and Spark. So I don't need to spin up a machine on Amazon just to be able to prototype and test with this stuff. I can do it on my local machine, on a small data set, and wireframe everything and see how it works. I think that's super handy. If for some reason I can't connect to the internet, if I'm out on the road or something, I can still do prototyping on my local machine. Yeah.
How is this different than spinning up my own local Spark cluster?
Well, you could do it locally, like in a Docker, instance or something. This just gives you the ability to set it up locally, just drag and drop, and you're done. And you can see the Spark UI. You can pull it up right within KNIME, so if it's doing the calculations, you can see exactly what it's doing. It's super handy. So, Charles? Yeah.
Kind of related to the big data stuff, like Amazon Redshift. Is that just an API?
Yes. Yeah, we have nodes that are dedicated for Redshift. So the nice thing about this is if I'm prototyping, I have a toy data set on my machine, I get everything worked out, and I think, okay, this is how I want to do it. Then I take my local big data environment node, I disconnect from that, and I bring in the nodes that are actually connecting to my cluster and run them. I don't have to do anything else. So makes it handy. One of the other ways this plays in is with H2O and Spark. So H2O has what's called the sparkling water integration to use H2O's super fast algorithms within Spark. And so because we work within both of those frameworks. We have nodes that support that directly. You can see that here. All you have to do is create, bring in this create sparkling water context, connect whatever your data is within Spark with these Spark to H2O nodes, and off you go. And so this is just kind of an example of like how you would do that. You want to prototype on your local machine. You want to use Spark on your local machine. You want to use H2O algorithms on your local machine. You can do all of that here using these new nodes for 3.6. And then later on down the line, we're doing, parameter optimization. We're doing a grid search for an H2O GVM. A bunch of different advanced stuff is happening, but it's all happening on my local machine. And when it's time to actually take this model and run it in the cloud, then I'm just swapping out some of these orange nodes. That's all I have to do. So I think that's, as someone who's kind of a big data novice, I think it's really cool. I'd much rather play around with it locally and not waste a bunch of money in an Amazon instance screwing stuff up. Okay, one other thing we have available in 3.6 is the Workflow Hub. So this is like a social, I used to call it the KNIME Social Workflow Repository, so you can see why we call it the Workflow Hub. But if you go to workflows.knime.com, you'll see this page. This is a workflow that I wrote for a blog post. You'll see a picture of whatever the workflow is, whatever description of it is there, whoever the author is, and then you have things like ratings, any comments, any versions of the workflow that exist will be listed, and then whatever extensions are required to run the workflow are listed. And then you can just click and download it and get it on your local machine. So this is like an extension of our example server. You can get to the example server within KNIME, but this kind of is going to give you information about the workflows, what they do. It's searchable. Just makes it a little easier to try and get to what you need. So there's a ton of features that I didn't talk about, but if you're interested, I have a link here and I can pass the slides around to Francisco later. You can distribute if you want to find out what's new in 3.6 and also the newest version of the server. Before I wrap up, I want to let you know two things. So we have a fall summit coming up in Austin. If KNIME is interesting to you, if you have a chance to download and play with it, you think, hey, I'd like to learn more from people who use it all the time, or from our data scientists. 6th through 9th is the summit. The first 2 days are all-day courses. So we have intro classes, of course, but then we have things that are specific to big data. We have classes specific to text analytics, whatever floats your boat. We have courses for that, and then Thursday and Friday are summit sessions, which are business use cases. Our founders will come in and give talks about what's going on with KNIME. So that's at the AT&T Center, downtown Austin. We feed you. So if you're interested, let me know. I have a promo code for anyone who's interested in getting to Austin. And finally, if you are interested in learning more about KNIME on your own time, and you download the software and you want to do some exercises and get an idea of what's going on, you download this book, KNIME Beginner's Life, from our website using this promotion code, which is Houston-0518. I think that promo code is only good till the end of this month, so if you're interested, you probably want to do it quickly. That's our thanks gift to you for coming out tonight and listening to me talk about KNIME. But it actually is a really good book for getting your feet wet and understanding the software. So I'll leave that up in case you guys want to take a picture with your phone or something. But that's all I have. So thanks for having me tonight. Thanks, Francisco, for inviting me. I'll stick around for questions and discussion, but otherwise, thanks, guys.
Thank you, good job.
I have a question. You've got all this interconnectivity with all these other softwares. How do you manage, or is it well managed, version control so that you don't have clashing between your nodes and what someone else is publishing?
It isn't always easy to manage that, right? To the extent that we can, we do. But if we're completely dependent on somebody else's library for an integration, sometimes we have to wait for them, or there may be some bug in the integration that we can't take care of that's on their end. We may be at their mercy a little bit. So we try our best to provide workarounds when we run into things like that.
So I guess that's my question. Is there, you you create another node just to sort of band-aid it until version control became compatible again, or how would, did you guys publish something in the meantime? How would that
Yeah,
work?
we do have bug fixes that come out periodically to address things exactly like that, where we identify deficiencies and integrations and stuff. So we'll fix stuff as quickly as we can. If it's not something that we can fix quickly, then, you know, like on the forum, we'll try and work with faults to come up with alternative solutions. So I don't have a really great answer for you there.
Well, I know it's a hard problem. I mean,
Yeah.
some people won't upload, right? Python comes out with a new version and no one will load it because they're waiting for their library to become current with it.
Right, I mean, we have, probably one of the most common questions I get on the forum will be it will be about TensorFlow and Keras, and it's breaking and they get a really weird non-descriptive error message, and it's invariably because they use this version of Keras and not this other version. And we just have to tell them to use this other one. Sometimes it's something like that,
But your
but
error messages, are they complete like that, where they give a hint as to that it's a version control problem as opposed to?
if we know that's the case, we'll try and make sure that error message gets updated until we can actually fix the problem later. So, I mean, our developers are really active and they try and stay on top of that stuff to the extent they can. Yeah.
I've been looking at Intel's Movidius, their little USB neural network sticks.
Okay, I'm not familiar with that at all.
Okay, well, apparently you can you can buy it just off the shelf for $70, get a deep learning neural network that plugs into a USB port 3.0 on any system. You can actually daisy chain them as well.
Really?
Yeah, and it hooks up to TensorFlow, and I didn't know if you guys had like a little component you could plug into that.
No, I don't think so.
And they don't really have like a good interface for it right now. And it's only been out for about 6
You
months.
say Movidius?
Movidius from Intel.
Interesting. Yeah, I'm not familiar with it at all, so I can't speak to that, but it sounds intriguing.
No, I just think this, if you got a hook for it, you can really.
Yeah, I could talk to our developer folks tomorrow and see if they've heard of it, or if they're, I mean, because if it is something that needs a front end and one doesn't really exist, then it might be something we'd be interested in working on. I'd have to see though. Yeah, thanks. Yeah.
You mentioned earlier, you hook up Tableau. Do you have a connector to Spotfire or Power BI?
Yes. Yeah, we have connection Spotfire.
And is that part of commercial or is it open source?
No, it's open source.
Okay, that's nice.
Yeah.
And then on the Git tracking, what exactly do you track? Like when I do a Git diff, what do I see, XMLs?
I'm not really sure.
Okay,
Those are new nodes and I haven't had a chance to play with them yet.
okay.
So-
No, like, you know how when you commit a script or data, you tell you the difference.
Yeah.
But this one, like, what exactly do you see when you do a Git diff?
Yeah, I don't think it's a diff so much as it is statistical information about who's doing what.
Oh, like just the data and who commit what?
Yeah,
I see.
when did they do it, what did they do, what files went where, all that sort of stuff. There may be a diff functionality that I'm not aware of, but I don't think that's the primary purpose, or at least not yet.
Okay. And do you know if there's an example for a multi-response time series node for this?
We have some time series nodes to do things like moving aggregations when we have nodes that are dedicated to ARIMA. So to answer your question, I don't know if we support that specifically, but we do have some time series functionality.
Okay, thanks.
Was there somebody over here? Okay.
You said you run this on Amazon, can you run it on Google?
I don't know. I think so. We're like really heavily into supporting Amazon and then Microsoft Azure. I think so. That's probably a question I should find out, huh? Google's kind of, they're important.
Have you ever been asked to like convert from like one infrastructure to your infrastructure, like from Microsoft SSIS or Informatica into your system? And what advice have you given people to do that?
Have we been asked to do it? Like for us to do it, no. I mean, customers will typically come to us because they're unhappy about some other product that they're using. And then, we have this feature set and we kind of explain to them the KNIME way of doing it and we try and teach and educate. But that's not something we've done for people.
I didn't know if like you had tools for like doing this or something like that.
No, not really.
Like text tools that you data mine.
No, I mean, it's, you know, we have some simple stuff. We have some nodes that will read, for example, like a SAS7 readout file. You know, if a bunch of SAS files, you want to get them into KNIME, we can read the files, but like, you know, we can't execute their code. It's proprietary, so you would have to develop in KNIME. You would have to reinvent that wheel, for example, as opposed to R or Python, which we natively support. So coming over from other software, I mean, I'm sure that's a pain point for folks that are gonna make that decision. But usually by the time they come to us, they've already made the decision. It's painful enough as it is. Anybody else?
Are you gonna be sticking around a little bit more?
Yeah, I'll hang around.
So if you guys are a little bit shy on asking questions. We had a lot of questions, so that's good.
Yeah,
That's
no,
really good.
that's great.
Usually some folks are the percent and there's no questions, so. That's good.
Everybody fell asleep, no question.
Yeah.
Francisco doesn't get a lot of questions.
I don't really, not, but, yeah, that's true. There's 2 more pizzas, so if you guys are still hungry, please help yourself. There's a lot of beer left, so I'm gonna take 2 road beers to get thirsty. Just kidding, live stream. I'm not encouraging alcohol. So just in case. So yes, yeah, help me out, please. These beers were so darn hard to get through here, Terry, so please help me with make some beer. Again, please, we're very excited. September, we're gonna have Women in Tech. It's gonna be a forum here. No, on the 10th floor. We were tonight on the 10th floor. And it's, we're gonna have some special guests. So it's gonna be a lot of fun. You'll hear, I'll set up the meetup in the next week or 2, and Flatiron's gonna market it all over the place. There's gonna be quite a few people. I'm buying the food for them, and they'll buy all the drinks. So, because I think WeWork, for some reason, they have a policy now where they don't buy any meat products. So
That's right.
if they sponsor anything anymore, it's all vegetarian or salads and stuff like that, or whatever. So that's a good thing that I'm buying the food now, because I'm gonna have my barbecue. No, I'm like, well, maybe if you guys and people like it, maybe I'll buy barbecue. But that's one of the policies that WeWork has, so it's kind of weird. So yeah, hang out, and the restrooms are just down the hall and to the right, all the way down, and women's and men's. So if you guys want to hang out a little bit, we'll be in here. So thank you very much, and we'll see you in September.
If you guys want to, feel free to come get my card if you just have questions, you know, in the next weeks. Certainly feel free to contact me.
Yeah.